sake of the people who are going to listen to it later, because you're not the only one with this question, and I'm glad you asked it, because some of these are it's a little bit hard to know how to show work sometimes, and that's why we're here. Okay, if you ever have questions about how to show your work, but you think you know how to show your work, feel free to send us a picture or send us a screenshot of it and we'll let you know. But in terms of what you're asking, that's fine, as long as you show us some kind of statement by alternate interior angles, or these are not alternate interior, these are opposite angles, which we don't have a
supplementary, complementary, even
something like
right. Okay, yeah, that's what I've been doing.
One thing I will say, because somebody else asked this the other day, and I want to make sure that I know what I was going to do. Give me 1 minute to check this. I just want to make sure that, because this would be a bad time for the internet to die.
Yeah.
If it did, I would just put you back in the meeting. It wouldn't be the first time. It would just be unfortunate if that was the case. Can you still hear me?
I can actually hear you fine.
Okay, cool. So just checking, because like I said, sometimes my internet does interesting things.
I think I saw that yesterday too. There's or the day before, there's an email. But
no, the day before I got stranded across town longer than I expected and couldn't get back in time. So I had to open up the meeting, but I wanted to message you guys to make sure, because I knew you had a hard work assignment that night. I'm like, it's going to be my night where new people show up. And then they're going to be like, what happened? One thing I will say is that here there's an exercise where they give you, and I don't remember what number. I can pull up the textbook if I need to, but since you seem to have it open, I know they give you one exercise where they give you something like this. They give you an angle here, and then they give you an angle here. And these angles themselves are not alternate interior angles. Okay. These angles are opposite angles. Okay, I think there's another line in the middle here like this. But the thing is, these two angles that I've marked, these are not alternate interior angles. They're not any of the angles that you can use to prove lines parallel. So in that case, you just write something like cannot prove any lines parallel because you don't have the proper angle, something like that.
Okay.
But there was a question about this particular one because somebody was mixing these up with alternate interior angles. So I wanted to point
that only happens with two lines and one transversal, right? Or two parallel lines and one transversal, not when there's, well, in this case.
Well, you could have, now it depends on what I give you. This line here, this line in the middle for these two angles doesn't really do anything. So you could conceivably, and that was the students' confusion when they asked this line is there, but you're really looking at the lines that you would have to be able to prove parallel would either be the bottom line with the top or the left with the right. Okay, but you don't have the right kind of angles to do that. These are just opposite angles. They're not alternate interior. They're both interior to this. Hold on. They're both interior to this set of lines here. Okay.
Yeah.
They're both interior to that, but there's if you're looking at, say, these lines here, right? Then this side would be your transversal. In which case, you don't have an alternate interior piece. And if you're looking at the top and the bottom, and this becomes your transversal over here, you don't have alternate interior angles either. So there's a difference between opposite and alternate interior angles.
Alternate would, so just so I can, you know, be
Sure.
able to recognize both of those, like, because for like that is for opposite angles, I can get that down as long as they're
We're gonna have
the
more
same
theorems
shape.
about opposite angles if you've done the sections on quadrilaterals and parallelograms, if you've gotten that far. Opposite angles of a parallelogram,
To
for
a later
example,
chapter.
are congruent.
Oh,
Right?
okay.
So there are, but it's not how you prove that lines are parallel. Does that make sense? It's a property of some of the shapes, but it's not, we don't have a theorem about opposite angles proving lines parallel, if that makes sense to you.
Yeah, that's why I actually wrote them all down
That's
on
good.
just one side, because that one did kind of confuse me.
They're also in your, I don't know if you're aware, but there's an appendix in your book
Okay.
that has, and I'll show you that after I answer your question. I don't want to get away from your question because it's a good question. Let's just take this set of lines here, okay? So if I'm looking at these two lines and they're cut by this transversal, right? Then let's say I have this angle here. So there's this becomes your transversal. Let's say I have this angle that's interior. Interior means between the parallel lines, okay? So when you refer to interior, for example, let's just do this because this is lost on a lot of students. So interior,
It's like a lane, you just can't cross
means interior is between
out.
parallel lines. That's what we're referring to when we talk about interior. So for example, before we talk about alternate interior, let's just talk about this. Here's an interior angle here. Here's another one here. Here's another one here. Here's another one here. These are interior angles.
Okay.
They're between the parallel lines, right? Now, exterior angles are on the outside of parallel lines. So here's the line. Let's name this line. Let's call it P. And let's call this line L here. And let's call this transversal T. Okay. So these angles in red are all interior. Okay. Angles that are outside the parallel lines on the outside lane here, these are exterior angles. They're outside of the parallel line, the parallel pair of lines that you have. So the green ones are exterior angles. These are exterior. Exterior is outside the parallel lines. So whoops. So those are exterior angles.
Okay. And
now if you're doing one more thing, now I can show you. Now if I'm doing, we have two other terms. This gets to sounding like a language class, so bear with me, because when they say math is a language, this is what we're talking about. When you talk about same side, we have same side interior, same side exterior, right? Same side means on the same side of the transversal.
Oh, okay.
Okay, and opposite side or opposite like alternate interior, right? Let me use that. Let me use this first. Alternate means on differing or opposite sides. I don't want to use the word opposite right now because I don't want you to confuse it with opposite angles.
Other one, yeah.
On differing side
Okay.
of the transversal. So it's actually pretty easy once you understand that that's what it is. But a lot of students don't quite understand it. So
I remembered it by the position, and that was still hard to remember. But this helps it separate between the parallel lines, which is easy to spot, and then the transversal line. Which
now, if you have, the thing is, and I'll do one with multiple pairs, you can only pay attention to a pair at a time. Okay. So the issue with that drawing for like, I think it's 7 to like 15 or something like that, is that there's like 6 lines in that diagram.
I think.
And students get lost in the diagram trying to, because there's like 20 some angles in there.
Yeah, for
and it's like
7 to 6.
7 congruent. Where is that
24
angle?
angles.
So yeah, and so what I tell them is find the 2 or 3 that they're talking about. Figure out which. Now, if you have some choices, because on some of those you do, right? Pick a pair, start with a pair, and decide if you can prove them parallel or not. And then pick the other pair. There's usually not more than 2 choices, like is M parallel to N or is N parallel to P. There's usually not more than 2, but start with 1 and then you'll be able to figure it out.
Yeah, I kind of see now for I think for example number 4, I think after, because you can also just look at the position too of it.
If you can see it, you can do that as well. Okay. And I'll pull up the book right now and show you that. I just wanted to make sure this was clear because I know a lot of students have difficulty with this. So I wanted to make sure this was solid. So for example, this is an exterior angle. This green one that my pointer is on. And the alternate exterior to this one would be on the other side of this line. So right now I'm on my right. I don't know if your computer shows up as reversed, but this is my right. The other side of it shows up here. Yeah. The other side, and it's exterior. So its alternate exterior would be this one. Okay. Alternate because they're on different sides of the transversal. Exterior because they're outside the parallel line. Okay. Yeah, that's a lot more now sense. Alternate interior, you have a couple more choices here. Remember, because we have 4 interior angles. These are all interior, the red ones, right? So here's an angle, this one. Now, alternate interior would be on the other side. So it's not this one because that's on the same side. Yeah. So if I'm looking at this angle, alternate interior means go to the other side of cross the transversal and find the interior angle right here. Alternate interior angle. Right here. Those are alternate interior. So are these. This one and this one here are alternate interior angle. But you have to have a transversal that you cross. Otherwise, if I remove this transversal here, oops, didn't mean to remove that. If you remove this transversal, come on, cooperate with me, probably won't. But I'm gonna see if it will. There we go. I'll have to undo some things. But these angles now are not all because there's no transversal. They're just opposite. If this was just a rectangle, if I just draw this, if I just draw a rectangle here, right? And I have, those are interior angles. But they're not alternate interior because there's no transversal for them to cross.
Oh, okay.
Now I could prove now here's the thing, if I extend, this is the deal, watch this, because this, when you start proving parallelograms, you're going to come back to this theorem. Watch this, here's another trick that we do. This is a geometry trick that we employ, and now it'll make sense to you, hopefully. If I take this and I extend this line, right here, and right here, extend that line. Now I have a transversal, right? Because this is the top and the bottom, right? I have a transversal going on over here. So then this, now if I want to show that the top and the bottom are parallel to each other, right? Then what I have here, I can use this line. I can use either side actually, but I'll use this line as my transversal. I can do that. That's legitimate, right? But if I'm using this line here, this angle, okay, there's this angle here, right here, right? Then I have to cross the transversal, so I would need an angle out here. That would be, I would need an angle here, which wouldn't be an interior angle to it. I would have to maybe do something with same side interior angles.
Oh, okay.
Something like that. Or I could show that these are, but I would need something out here to do it. I can't do it with these angles.
Mm-hmm.
Because that's not this transversal, you see. I could use it with this one, but they have to be talking about the same transversal for me to do that, right? If I'm looking at this angle, I can match it with this one because they're both interior to those parallel lines, but it's not inside the rectangle itself. You see where that's coming from? So that's a long-winded explanation to the whole, but I hope that helps you see it a little bit more.
I understand it more on the way you explained it versus the textbook.
Yeah, the textbook usually does a good job, but this section got a little bit, I agree. And a couple of the directions and a couple of places are really like, let me figure out what I'm supposed to do. Because
that's why I always have trouble with when it comes to math theorems, because usually those are explained very in a way where I'm like, I can't even picture it in my mind.
Right.
Or even the theorem itself being proved. But
how are the PowerPoints for you in that way? Because she tries to give you pictures of most of them.
I like the PowerPoints. I always have those out. The videos with the gentleman, with the man, he's pretty good. he saw it.
Yeah, those are supplemental.
Mhm.
So you're not required to watch those, but if they help you, then fine. If not, feel free
Yeah.
to
Uh-huh.
not always, you don't have to watch those, but if it helps, then by all
Yeah,
means.
her PowerPoints are pretty self-explanatory. The textbooks so far, the only ones that have helped are just like problems that already include like doing a lot of math. 'Cause
Right, right.
they
No, I
show the
know.
steps.
I
I
I
love that.
I totally feel your frustration there because
I've been taking geometry since high school, so just like a lot of it is like coming back to me.
it's all coming back to you now. So
Yes.
let me put this up on the screen in case you have anything else that you, how are the other sections? Have you tried any of the other ones yet?
Yes, the others are actually pretty good. I guess, for example, like section 2.4, a lot of it has to do with either if they're supplementary or if they're also, let's see here, like also
Complimentary,
finding their measure of an angle within a
right?
triangle. Pretty,
Mm-hmm.
yeah, I understand those parts. And then for 2.4, anything with triangles, I'm pretty good with that.
Triangle,
Um,
okay.
and then as far as the homework, that's also due. Let me just make sure I have that here. Yeah. I haven't gotten to polygons yet.
Okay.
For 2.5. That's all that I have left for the
Just
homework.
keep in mind that you have the quiz.
Mm-hmm. That's why
So
I'm like I didn't take that yet. Because I just didn't
um
want to go through the quiz and for and before I even do tutoring for it. But
okay.
convex they're due tonight, so yeah, that's kind of on my end. But I'm sure her PowerPoints are gonna help me out too.
But I will tell you, and you can go ahead and pull the quiz down. So I'm not telling you anything you don't know, or that you don't have access to.
Mhm.
One of the problems on the quiz is very much like this example. It's not the same.
Mhm.
The picture is the same. The math, the
Right.
expressions are different.
Okay.
But it's similar to this example here.
Mhm.
Okay, so that's one of them. There's a question about the interior. So that is example 5 from section 2.3
Mhm.
will match one of, not match, but it will parallel one of the examples on your quiz. There is a question about the types of polygons and the number of diagonals that your polygon has versus the number of sides that it has. So there
Oh.
is a question about the sum of the interior angles versus the diagonals. So I'm just going to point this out because for some reason, this gets hidden from students and they can never find this formula. And I've had a hard time too. If you need to find, bless you, if you need to find the number of diagonals, it's right here. The number of diagonals, once you find the number of sides, it's theorem 2.5.1. Because she's going to ask you about the number of side. Now, there's one about the interior. So there's the sum of the measures of the interior angles, but there's also one about the individual interior angle. Okay, so be careful with that. There's an example that's actually similar to example 4 and example 5 from this section. So you're using one, the difference here, and the reason I'm pointing this out is that this formula here, I equals, this is n minus 2 times 180 over n.
Mhm.
The reason that I'm pointing this out is that students mix up this formula, this I is equal to n minus 2 times 180 over n, with the formula that I just showed you, with the formula for S, or sometimes with the formula for D, the diagonals. So the formula for I, see, we don't want to use this S. You don't want to use 2.5.2 unless you're looking for the sum of all of the angles. Okay, the formula for I is one interior angle, one of them, okay? And you're going to use this formula on the quiz for one of the problems that's actually on there, okay?
That one is 2.3.
2 point, yeah, the theorem or the example?
The one that you said to make sure to separate, because I have those all the sum one down, but the one angle.
The interior, right here, it's on example 5.
Oh, okay.
Of 2.5. Oh, you want the theorem number where they give it to you?
Yeah, I was the one.
Let me look for it. I don't know what it is, but it would be good to have that.
2.5.2 is the measure of all interior angles.
Yeah, and then there should be one with a singular. Probably the corollary of
corollary. Yeah. It was a corollary.
Yeah, it's the one, it's on the bottom of page, I think it's 2.5.3 is what I see here.
Corollary.
On page 102 at the bottom of your, it's page 102 of the physical text or page 122 of the ebook.
Okay. Good, thank you.
Okay, that's just from experience. I know students tend to mix up those two and then they're like, why can't, because you'll know, because you'll get an answer that you'll have like a number of sides that's just not, and they're like, what did I do wrong? I'm like, this is for one interior angle, not how many sides you have. So yeah, those two for some reason tend to confuse people. And then there's a couple of proofs that she asked you, but the proofs are pretty straightforward and pretty basic. You should have as many statements in your proof as there are lines on the quiz itself. Okay, so you shouldn't need more lines than the quiz gives you to fill it in. If you have more than that, you're probably trying to state too much.
Yeah.
So just, I can bring it up because this is blank. So this,
yeah, like the perpendicular
is your, so here, let me show you. This is the quiz, okay? And like I said, it's available now, so I'm not showing you anything you don't have access to. Here's what I was referencing here, okay? Make sure you show all your algebra for how you got that. Again, same kind of thing as the example that I referenced, but just different expressions for the angles, okay? But same kind of thing there. Here I am. Each interior angle, so here we're talking about the I. This is I equals 180 times n minus 2 over n. This is the corollary theorem, okay? So she gives you what each interior angle measures. You will need to find n. And from there, you'll classify the type of polygon. And then you'll use the formula for the number of diagonals. So make sure you use the diagonals formula, not the sum of the angles, okay? But that's number 2. And then number 3, is just, I don't know exactly where, I'd have to look it up but there's a diagram that looks very similar to this. You did a proof that was similar, or you will when you get to that part in the homework. But this is very similar to a proof that you've done already. So that's there. And then the last one is this one. And again, there's a picture that's very similar with a proof that's very similar. So these are usually where students get a little stuck. This proof is a little bit longer, but you're also given more things. So just put it together. It's proofs are hard. Okay, so just do the best you can. There's a whole section that comes with proofs, so the pain is kind of there for a while, and then eventually they sort of taper off, but they come back on the final. So just do the best you can. We know that that's hard, and as far as the homework goes, we're more than willing to help you with that. If you want me to take a look at it before I have a meeting for the statistics class tonight after this. So I'll drop the link in the Pronto chat for geometry, and if you guys want to come by and have me look at it, I can. But otherwise, this quiz is really pretty straightforward. Don't let it scare you. It's not.
Yeah, I was gonna say I had one quick question though. I'm not sure if I'm able to have a.
You can ask me a question. No, you can ask a question. You're always welcome to ask questions about the quiz or the exam. The thing is, I can't solve them for you, but I can give you hints about them. Okay. Perfect. But what I can do is, if you show me your work, or you send us a screenshot, something like that, I could say, hey, go back and look at this step again, or look at this theorem here, or something like that. And by all means, if you happen to find a mistake or something that you think is a mistake, let us know. Okay. I've looked at this, I think it's fine, but every once in a while somebody goes, oh, you're missing a number, or oh, you forgot to tell us this. If you think it's a mistake, better to ask us than not. We're not going to jump down your throat. If it happens to be something that I can't tell you, I'll just say I can't tell you. But I'm not going to withhold information from you just so you can't do the question. So yeah, by all means, do that if you have a question about. Yeah. Now, can I answer it? Which one is your question on?
It was the ones that you said that confuses everyone. I guess I had a question about like the very last ones with the statements and reasons and proofs.
The proofs, okay.
Just because I see, like, for example, number 3, or actually the other one before, it was, I think.
Now, are you talking, okay, if you're talking about the formula, you're talking about number 2 here.
Oh yeah, no, not that one. It was there was one that said it had a lot of more information, you said. So there was a lot more.
Talking about this one here. I said that this is a longer proof than the previous one. Because there are more givens in here.
So in the statements, we have to, is it saying like to write a statement and a reason for each of those given?
Okay, so the givens technically, usually the givens are in one let me show you something here, because I think I know what you're asking. So let me see if this clarifies. If it doesn't, you can let me know, but let me see if I can clarify this. Because I did not mean, generally, the more givens you have to do a little more work, is where I was going with that.
Because you're not looking at one relationship anymore, you're looking at.
And so sometimes people are like, but what do I do? And I'm like, the same thing you did the last time you did it. It doesn't change. It's just, you have to apply the theorems that you already know. Okay, or the theorems that you're looking up. That's what That's the point of it. And that's what makes it hard, because a lot of times you've just learned the theorem and it's like, where's the theorem that's why you take notes and you look at the, let me find the book again, because I had the book open and it's disappeared on me. So let me find it again. Oops. Now I've got like a bajillion windows open. Give me a second here. Okay, geometry, there it is. Okay, if you look at this example, you look at this here. Let's share the textbook screen. If I'm looking at, let's say I do a proof, I'm going to go to one of the proofs that they show. I have to find one, but they're not in, there's not a whole lot of them written. But here's, for example, right? Here's a proof that they wrote. This is a proof about parallel lines, right? So what they did here, this is example 3 on section, what section is this? 2.3, I think. Yeah. It says, here we have a diagram, right? Standard 2 parallel lines, or 2 lines that we think are parallel with some angles marked and a transversal here, right? Prove theorem 2.3.4. What does that say? Well, if 2 lines are cut by a transversal, so there it is, right? So that the interior angles, which angles are interior angles in this diagram?
1 and 2.
1 and 2, right? On the same side, they're on the same side, they're both on the right, are supplementary. So we're trying to show, remember, what does supplementary mean?
180.
They add up to 180. Then the lines are parallel. We want to prove that. So they say, given lines L and M. Okay. Now notice they didn't tell us L was parallel to M. They just gave us lines L and M. And they gave us that T is a transversal there. Okay. Right? But they gave us another piece of information. They said that angle 1 is supplementary to angle 2. They told you that. So when you want to prove then that L is parallel to M. So they set it up for you, basically. This if part, if the 2 lines are cut by a transversal so that the interior angles on the same side are supplementary, that's given to you. That if is given. We're trying to prove the then part. Then those lines are parallel. Okay. So they've set it up. So here's what they did. They started with the given statement. So on the side where it says statement, you write the things that are given to you. Okay. Now, if you write all the givens at once, that's okay. Okay. But for some proofs, it makes more sense sometimes to split the givens and do part given and part not. If you write all the givens on one statement, that's not wrong. Okay. But you write the statement and then the reason is it's given to you. Okay. That was given to you, and I lost the page I was on. Let me see where I'm at here. Here it is. Okay. So that's given to you. The next statement says that angle 1. Now, remember, they gave us that angle 1 is supplementary to angle 2. They're going to establish something for us that angle 1. Notice we have another angle in the picture, don't we?
Angle 3.
Right, because we have to find a way to establish some kind of supplemental relationship here, right? So angle 1 is supplementary to angle 3. Okay, so why would angle 1 be a supplementary to angle 3? Because they're adjacent angles. They're on the same straight line, right? So they wrote, if the exterior angles of two adjacent angles form a straight line, then these angles are supplementary. You could write linear pair, you could write adjacent angles on the same line are supplementary. The language has to be close. It doesn't have to exactly
I think that's the hard part, the language.
mirror this wording.
Yeah, it can.
Okay.
Yeah.
But a lot of these reasons are going to follow from other theorems. Okay, so use other theorems to help you. Okay. Then they said, okay, now you've established that 1 and 3 are supplementary. What can I say about 2 and 3 now? Well, if 2 angles are supplementary to the same one, because notice what we've done. They gave us that angle 1 was supplementary to angle 2 already.
Mm-hmm.
So 1 is supplementary to 2 already. You've established that 1 is supplementary to angle 3 by the fact that they're adjacent. So now angle 1 is supplementary to angle 2 and angle 3, right? Therefore, now follow this logic. Angle 2 and angle 3 have to be supplementary to each other.
So I think for that part, I always get confused to say like, oh, it's the they have to equal supplementary 180. But just because I see them like in the same position, they look congruent. But that's because we haven't stated that relationship between L and M yet. Right?
Okay, well, okay, so I think you're thinking about corresponding angles.
Yeah.
And they are. 2 and 3 are
corresponding.
2 and 3 are congruent.
Congruent.
But they're also supplementary to angle 1.
Oh, okay.
Right? You're right. Okay. You're correct, but that's not going to help you prove the statement that you're proving here.
Okay.
Because what are you trying to prove here? You're trying to prove that L is parallel to M using a supplemental relationship. Okay. Now, you can you end up with corresponding angles as number 4.
Oh, yeah.
But the reason here, I can't say they're corresponding until
L and M are proven.
Until I actually prove that they're congruent to each other.
Oh, I see. Okay.
You see what I mean? Because remember, I don't know. Here's the thing. I don't know that these are parallel yet. See, if you jump number 3 and go to 4, right? And tell me these are corresponding angles. That only works because L and M are parallel. But what you've done there is you've assumed that what you're trying to prove is true already.
I skipped the step.
Does that make sense? So yeah. Your thought process is right on there. But you have to, all you know right now is 1 is supplementary to 2. And that 1 is supplemental to 3. Okay. Now, if that's true, and then it is, then 2 and 3 have to be supplementary to each other, right? And they have to be congruent because they are supplements of the same angle. So here's what's going on. It's like a train. It's like a train. If I said if I said this, if I said, oops, let me go over here. All right, let's say I have angle 1. Let's do a little experiment here. Angle 1, right? Let's make a measure for angle 1. Let's say angle 1 was 80 degrees. I have no idea what that is right now. I'm making up numbers at this point. Angle 1 is 80 degrees, okay? Now, if angle 1 is supplementary to angle 2, then that means that angle 2 has to be 180 minus 80. That has to be 100 degrees.
Mhm.
So far, so good, right? Angle 1 is supplementary to angle 2. Now, if I also know that angle 1, which is 80, is supplementary to angle 3, angle 3 over here, right? Then that makes angle 3 100 degrees. You follow me? Because now they're supplementary for different reasons, okay? Angle 1 and 2 are supplementary because they told you that. Angle 1 and 3 are supplementary because they're the same piece of a linear pair. They're adjacent, right?
Mhm.
But see, here's angle 1, and what we're saying is angle 2 and angle 3 are both supplements to this, aren't they?
Oh, I see. Well, now how it's saying. I thought that you meant like supplement to each other.
Well, they are.
Like
Everybody is supplemental to everybody else.
Oh,
but it's like a train. If I said, okay, let's do it like this. Let's visualize it this way. Suppose I'm going to visualize this in a different order, but let's say I did this. Here's 3 train cars. Okay. So you've got angle 1 over here. You've got angle 2 over here. Let me draw. This is angle 2. And this is angle 3. Okay. Now, angle 1 is supplementary to angle 2. And angle 2 is supplementary to angle 3. Now that means that, let's say this is 80. This is 80.
Mhm.
Right? This is 100 now. Because angle 1 is supplementary to angle 2. And angle 2 right here is supplementary to angle 3.
Which is also 80.
Therefore, I can say that angle 1 and angle 3 are both congruent. Why? Because they're supplements to this same angle.
Mhm.
You see, that's what it's saying. Does that help a little bit more?
It did, yeah, because I think when I saw it the other way, or at least in the textbook, or sorry, on the
It takes a minute but that's what this is actually saying to you. So if you know that those two are supplemental, then they have to be congruent to each other. And then if they're congruent, now those angles become corresponding angles. as you said earlier. They become corresponding because of where they are in the picture, right? Here's our picture, right? So now I've proven that this angle, let me annotate screen. Okay, so, oops, that wasn't what I wanted to do. I mean, I wanted to do that, but not like that. All right, so let's try this. So here we are. See, this is supplemental to this, 1 and 2, right? And 1 and 3 are supplementary. That means that because 2 and 3 are both supplements of the same angle, 2 and 3 are supplements of the same angle. 2 and 3 have to be congruent. They have to be equal to each other. And if 2 and 3 are equal, they're both, here's a line, here's an angle above a line, right? Here's a line, here's an angle above a line. Those are both corresponding angle now, right? Because there's a transversal there. That makes these corresponding angle. And if they're corresponding angles, bingo. Then we can say that L must be parallel to M.
Okay, now I get it. Now it's not in the way that train, for example, like the measure of the degrees. I was thinking of adding them up, but what you mean is like a link.
It's there, it's transferring it. It's like a cargo.
Yeah, it's like you're kind of digging deeper to find the ways just to prove this.
Right. But what I needed you to see, because what's hard to convince students of is that these are congruent. They're really like, how is 2 congruent to 3 if I can't say they're corresponding because I know they are? Right? But why can't I just say that they are? Because I don't know this is parallel yet.
Right, and then the questions, it usually says that lines L and if lines L and M are parallel, then what is angles 1, 2, 3, whatever
Exactly.
it could be.
Exactly.
Okay.
You're so you were using the right, you see what I mean? You were using
I had the right information, just not in the right order.
But you were proving, so it's kind of like if I said to you, Dolly Parton is famous because she is well known, right? Well, yeah, that's assuming the truth of what I'm trying to prove. If I'm trying to prove that she's famous, right? If I want to give support to that, she has Hall of Fame awards, she's been recognized by the, whatever it is. If I just say she's well known, then I'm assuming the truth of what I'm trying to prove to you. And that doesn't work for presenting a logical. So what I had to do was find a way. I had to find a way to make 2 and 3 congruent. I had to find a way to prove 2 and 3 to be congruent. And so that I could then say that they're corresponding angles.
Yeah, I think that was like in chapter 1 or 2, the list of theorems that talk about congruency and corresponding. I just need to go back to that section. And
there's also, I was going to show you that. So thank you for jogging my memory. So I wanted to show you this because this is actually very useful. Yep. Students find it useful in varying degrees, but a lot of students don't even know it exists. So I want to show you this. If you have the ebook, and you should because it's there, you also have some very useful appendices at the back of your book. And if you go down to the section on appendices, there is an appendix B. Now, constructions, we don't do in this class. You're not responsible for constructions. If you've done them before, If you find them interesting, they're there. Okay. But what I think is handy, especially when you're studying or sometimes when you're doing the proofs, it doesn't have every single, but all of the postulates and all of the theorems and corollaries, they're in separate sections, are there for you. And they're numbered. They don't have a page number, but you could go back and you could look it up by the number, but they're all here.
Yeah.
So instead of like, and I'm all for taking notes, I'm all for using the slides, but some students find this useful.
It looks like it could be.
I just wanted you to know that it was back here, because if you're one of those students that likes to go through and check the theorems and what can I use? Not that sometimes this backfires. You have to know yourself as a student, because some students are like, oh my God, saved my life. And other students are like, all this did was confuse me more.
No, I think I'm the one that where this saved my life.
So it just,
Thank goodness.
that's my caveat to that, because I've seen both. And it really depends on what kind of student you are. Okay. So, but it is back here if you want it. Okay. We are not going to memorize. You're never required to memorize any of this. You always have access to this, but just know that it's here if you want to use it. Okay. The other thing which you may or may not have discovered is there is an appendix. It doesn't have all of the proofs. It doesn't have all of the exercises. It has most of the odd ones. There is the occasional error in here. So if you do think you have an error and you can't quite get, then by all means, email us and we'll let you know. Okay. But you can check some of your work with this. You're more than welcome to use it. Just don't write only the answer down, but you're more than welcome to check your work back here and use that as a resource. So that is back here if you want to use that. There's also, sometimes this is useful if you need some definitions, if you have some trouble with some of the terms. The glossary in this book is pretty extensive in terms of the vocabulary. So if you ever have a question about, oh, what is an acute triangle? Okay, it tells you what an acute triangle is. It tells you, and it's in alphabetical order, just like a dictionary. So you might have to look, but it does tell you, for example, what a polygon is. Okay. And so you can look it up if you need it. It's here. Okay. So there's actually some decent resources in the back of this book. And I would suggest, and for some of the chapters, like I said, for chapter 2, it doesn't have all of the proofs. Okay. But especially at the beginning, it has quite a bit of proofs in here, and it shows you. So if you look at some proof that's similar, you can kind of see the structure of what's going on with that. And there's proofs in the examples as well. They don't do every single proof in every single section. They don't even always do all the odd proofs, but they, especially at the beginning, they do quite a bit because they realize that it's new. So you can check your work on some of the proofs, because I know that when you start that, that's difficult, and that's difficult even after you experienced. It's one of the more difficult things that we do there. So
yeah, I always have tough times with the logical parts of math, which is, but now I actually get a little bit more. Or at least now you kind of showed me a tip on how to keep them organized, because you're right, they're not meant to be memorized. And so
you will probably, honestly, you're probably going to memorize a few. Okay. Just because God, we use them so much, like you're gonna be like, okay, I don't even like I'm gonna remember this when I'm 80. Like I might not even know what an alternate interior angle is, but I'm gonna remember that.
But I know what it is.
So, but yeah, that's not her focus. Her focus is on, can you use it? Do you understand what they are?
Yes.
So just know that, and you're more than welcome to, like I said, use that and work on that.
I'm gonna print these out.
Sound yeah, maybe just print the first couple pages that you need,
Yeah,
first of
that
all,
gets you
instead of
intimidated.
like 500 theorems to help you in geometry,
There you
But
go.
the nice part about it is some students find it helpful to print the slides because she has the theorems on the slides, and she generally has pictures of what they all look like. That's by design. So, but like I said, if I'm trying to kind of teach proofs, like if the student has gotten to the point where they understand the structure of given and reasons, and they understand where that's coming from, because that's a whole other part. And some students, it's one of those things that should maybe be more obvious than it is. But there are some students that I have to actually directly teach that, like, this is the T structure and this is how you do it. Once you get past that sort of initial piece, and once you start understanding how to mark the picture, and I highly suggest that whether you're taking the quiz or you're doing the homework, if you're doing a proof, mark the diagram. Make a copy of the diagram. If the diagram's too complicated, take a picture, put it, just so you can mark it. Whatever you need to do something that's going to help you. But once you can get through all of that, then that's sort of the first initial, do you understand how all that works? Then it's like, okay, how are you going to go, before you start to write the proof, how are you going to go about in general doing this? Kind of like what I took you through with the supplement right then. Like, what are we going to do before we start to prove it? Then say, okay, what theorems do I need? That's when that list comes in handy, because it's like, what theorems do I have about supplementary angles that I know right now? Don't use a theorem you don't know. Don't use a theorem that hasn't been introduced, because she's never going to do that to you. If the theorem hasn't been introduced, you're not responsible, even if you know it. I had a student last week that he had geometry before, and he was like, well, I know these angles are because and he knew something about polygons already. And I said, that's great, but you're not, and it's not that it's bad knowledge, it's just you haven't been introduced to it yet. So you don't want to put that, because you're not responsible for that. She's never going to make you responsible for something that you haven't been exposed to. Other teachers might do that. She's not going to do that to you. So if you haven't been exposed to it, then she's not going to make you responsible for it. Now, you are responsible for prior knowledge, like understanding how algebra works, understanding what those terms mean.
I think that's under the appendix A, right? The algebra review.
Right. There's algebra there also. If you are particularly stuck on some particular, because a couple semesters ago, I had that. I had a student that was, and if you need that, we have resources for that. I'm more than happy to help you, to find you, so that, watch this 20 minutes of this, or practice these and go through and practice it. Usually it's just a matter of refreshing a skill that you already have. But sometimes it's, oh my God, I swear I never learned this. Let me.
I did that in 10th or 10th grade.
Yeah.
And then
so some of these skills kind of dust them off and bring them back, so.
Yeah.
But just
You're
know
way
that
better than my high school teacher, let me tell you that. He was a part-time tennis coach, so
so you got that down. All right, cool. So we
yeah.
don't have to worry. But I'm just, I like people to know that it's there if you ask for it. So this
Yeah.
class is
If we
starting
do get a
to kind
master
of come
language.
alive, but you guys have been really quiet for the first few weeks. I was telling somebody, I don't know if y'all are getting all the material or you're just kind of like overwhelmed or scared of us or what, but I hadn't heard from too many of you, seen pretty much anybody. I'm like, are they alive out there? So,
Yeah, my favorite part are the numbers. Because I have taken math, not geometry itself, of course, 7 years, but algebra, I took that 2 years ago, and I enjoy algebra or any kind of,
yeah, so the algebra part of this is probably not intimidating to you.
formula.
Some of the other parts of it, some of the later chapters might be a little bit harder. We do have some algebraic stuff scattered through most of the chapters. There are some chapters that are very geometric in terms of you see this relationship to this piece and that's a little harder for some students. So just don't be shy, just ask us. We generally respond to emails within no more than 24 hours. So just I usually try to respond within 12 hours, but after like about 7 at night, I usually shut things down and bring it up the next day. But you're more than welcome to email. What I will say, and it sounds like I'm preaching to the choir, but I'm preaching to the future listening audience here. If you do ask a question, feel free to Canvas message me and copy Professor McDell and vice versa. So if you message her about a question that you have on the homework, you can message me. The only thing that I won't be able to answer for you is anything about your grades or your score. Now, if you come back and say, I took this quiz and I'd like to go over numbers, I can help you go over the material. But in terms of, I think there was a mistake in the grade, or I want to talk to her about my points on this, I don't have any access to any of the assignments you turn in after you turn them in, unless you come and bring it to me. Like, I don't have any access to change any of that. And that's by my choice and by design. It's an integrity measure to protect you and me both. She's more than willing to, if you send her an email, or, I had a student that was like, I'm kind of like leery. I want to make sure that I'm on solid ground before I approach her. And I'm like, I'm happy with that too. I'll be glad to write her an email and say, hey, can you look at X's work on this? They want to discuss, I'm more than happy to do that, but believe me, she's not going to take your head off for that. So, but I can't change that. And I always like to tell students that because sometimes they think I can. So I don't have access to do that. So anything about your grade, your score, any kind of extension that you might need, that has to go to her. But I'm more than happy to sort of interact, put in a word, or like, I'm scared to, I get it.
I understand that too from others. So a lot of people are still not able to open up to a teacher or their professor just yet. And then me, I just have had so much experience with that. So okay.
Just some, yeah. So anytime. Nice to see you. One other thing I need from you, and I'm gonna turn off the.
Yeah, it's past 6 o'clock, and I know you said you had a meeting, so.
I have a meeting at 6.